Alright, this is going to be the first of several videos that I'm about to record in succession. So this is RAT2, multiplying and dividing rational expressions. So here's the key concept for this particular lesson. To multiply rational expressions, multiply the numerators together. So you multiply the numerators together and the denominators together. Then reduce. Now we've done this process before. With regular fractions. We've done this with, say, like 1/3 times 2/5, stuff like that. But we haven't done it with variables yet. So this is a bit new. Now, just as a reminder, when we multiply fractions like this, when we multiply rational expressions, when we say multiply the numerators together and the denominators together, we're really multiplying straight across. This is something that we can only do with multiplication and division. Well, division works a little bit differently. We'll get to that in a minute. But with multiplication, we multiply straight across. That's not true if we have stuff like addition and subtraction, which we'll get to with the next video, RAT3. So, when we multiply these two rational expressions together, on the top I'm going to have whatever 2x times 7y squared is equal to. Notice how I'm not writing it as 14xy squared yet. And on the bottom I'm going to have 3y times 4. Notice how I am not writing it as 12y. There's a reason for this. So now we have some parts of this fraction that we can reduce. Now, reduction is not the same as cancellation, but it is very similar. For example, I have a 2 and a 4. I can reduce these two, and I'm left with a 2 on the bottom and a 1 on the top. Alright, now I'm going to actually do this again, but in a different color, just to differentiate what was originally part of the fraction and what reduction is. So, I have my blue pen here. So I'm going to reduce this 4 to a 2 and this 2 to a 1. This is because 2/4 reduces to 1/2. They both have a 2 in common, so I pull a 2 out of both of them. And that's okay. Even though these weren't part of the original same fractions, like this one was part of the first fraction and this 4 was a part of the second fraction, they're still being multiplied together, so I can cancel across like this. And that's perfectly fine. You can also cancel straight up and down, although we won't really have to do that. Okay, y and y squared reduces to a y on top, and I don't really have to put anything on the bottom. So I'm left with, actually on that point, I don't really have to write this 1 either. Because 1 times anything, in this case x7 and y, is just x7 and y. So I don't need to write 1s, and I don't need to write anything when a variable does not reduce to anything. So for example, this y squared reduces to y, and this y goes away. This y on the bottom goes away. Now I'm left with, that 2's gone, so I'm left with x, 7, and y over 3 and 2. This 3 has stayed because it hasn't reduced with anything. You can't reduce 7 and 3 because they have no factors in common other than 1, which is redundant. And you can't reduce this x because no other term in this fraction has an x. So now we're left with this fraction. And so my final answer is going to be 7xy over 6. Now we're going to do the same thing with this one here. We have 6c over 5d times 15cd squared over 8a. On the top I'm going to have 6c times 15cd squared, and on the bottom I have 5d times 8a. Now once again I'm going to try to find things that I can reduce. For example, I have a d in both the top and bottom fractions, so that's going to become d squared over d. That's going to give me a d on top. Again, this 2 real quick was part of the previous problem, so I'm just going to write that off to the side so that it's not confusing. What other things can we reduce? Well, we have two c's, but they're both on top, so we don't reduce this. We don't reduce the c's because they're both on top. It has to be one on the top and one on the bottom. So let's go to the numbers. We've got 15 and 5. They both have a 5 in common, so that reduces to 3 and 1, which we don't have to write. Then 6 and 8 both have a 2 in common, so this reduces to 3 and this reduces to 4. And now I write out all of my parts. So I have 3 times c times 3 times c times d over 4 times a. Which leaves me with 9c squared d over 4a. Okay, so now we've got this right here. This third set of fractions here, we've got 12c cubed d squared times 14a squared b divided by 21ab times 8c squared d. Okay, real quick, there is actually a second way to do this that I will show you now. If you really need to, you can write this all the way out, and I'm going to do this on a separate piece of paper, because it's not the way that I would recommend students at the Algebra 2 level to do this, but if it helps you, you can. So if you need to, if you can't see, for example, that 6 and 8 reduced to 3 and 4, we should be able to at this level, but if you don't, it's okay. It's just going to mean you're going to have to take a very long time to do some of these problems, and you might need a second day to take the unit test. But regardless, let's see, 12 can reduce to, if you break down 12 all the way, you get 2 times 2 times 3. C cubed is c times c times c. D squared is d times d. (14) is 7 times 2. A squared is a times a. B is b. And on the bottom I have 21, which is 7 times 3, times a times b. 8 is 2 times 2 times 2. C squared is c times c. And d is d. You can write it all the way out like this if you need to, and then cancel everything instead of reduce. Cancel everything that's common between the top and the bottom. The only downside to this that I can see is that it takes a very long time to reduce everything. It takes a very long time to properly reduce everything, and sometimes it's easy to lose track of some of the parts that you have left. And on top of that, it's a bit messy, and you have to make sure you break everything down completely, because if that's a 4, for example, sometimes it's hard to see that 4 breaks down into 2 times 2, which cancels with another 2 times 2. It's a bit of a mess sometimes. But you do get the same answer. We're left with these 3 parts on the top. So when we do this through reduction instead of cancellation like this, this is expansion and cancellation. The way that I'm going to do this and the way that I have been doing this is through reduction. We should still get A, C, and D on the top. So let's find out. So let's reduce. We've got 14 and 21. Oops. Sorry, forgot I'm doing this in blue. So 14 and 21 reduces to 2 and 3, because they both have a 7 in common. 12 and 8 reduce to 3 and 2, because they both have a 4 in common. Alright, c cubed and c squared reduces to just a c on top. This 4 was from the previous problem. D squared and d reduces to a d on top. B and b, they just straight up cancel out, so that's done in black. then a squared and a, you're left with an a on top. Okay, so far so good. We have the a, c, and d that we're looking for. This time we have more. That's because we now have a 2 on the top and bottom that can cancel out. And we have a 3 on the top and bottom that can also cancel out. This is very easily missed. At the Algebra 2 level, there are some times where when you do reduction, you'll have to reduce twice. And that's perfectly fine. This method is still much faster than doing cancellation like this. So, what are we left with? We're left with the C here, the D here, and the A here, just like we were left with when we did cancellation. So we have C times D times A, and everything on the bottom has been canceled out, or reduced. Sorry, everything on the bottom has been completely canceled out. So we are left with C times D times A. Now when you're left with 3 variables like this, the best thing to do is put them in alphabetical order. That's just simply the best way to write it. So our answer is ACD. Now we move on to division. To divide rational expressions, you do multiplication, so you multiply by the reciprocal of the second fraction. Okay. Now what does reciprocal mean? Reciprocal, this little word here, reciprocal, this means you flip the fraction. Now what does that mean? That means the numerator and the denominator swap places. Again, this says flip the fraction. I know that's kind of hard to see with this poor quality document camera. I don't know why the quality has gone so far down from what it was before. Yeah, I'm trying my best, guys. This quality is way worse than what I'm used to. Alright, anyway. So, in order to do this, we are effectively turning this division problem into a multiplication problem. So, the first thing that we're going to do is keep the first fraction the same. So we've still got 18xy cubed over 7a squared b squared. Oh, also, one very important thing that I would like to note, because I did, and this is a bit off topic, but I'm just going to write this down now. If you are watching this without sound, you might as well not be watching. I'm serious. There is no point in watching these videos if you're watching it without sound and just copying everything down. You are not getting the point. You might as well not be watching this at all. Thanks. I'm only going to say that once. Okay. So, we've got our first fraction the same. Now this is the part where we multiply by the reciprocal of the second fraction. So we're going to take the second fraction here and we're going to flip it. The numerator and the denominator are going to swap places. And we get, instead of 12x squared y over 35a squared b, we get 35a squared b over 12x squared y. And now we do the same reduction process as before because the division sign has been replaced with a multiplication sign. So in order to turn a division problem into a multiplication problem, you flip the second fraction and then change the division sign to a multiplication sign. Alright, so, oop, I did it in the wrong color again. Also, feel free to pause the video if you feel you can reduce this on your own. Actually, yeah, take a second to reduce this. And then unpause the video, and I will reduce it and you can check your answer. Okay, so 35 and 7, they reduce to 5 and 1. 18 and 12 reduce to 3 and 2. And now we have the variables. A squared and a squared. These just cancel out. b and b squared reduced to b on the bottom this time, x and x squared reduced to x on the bottom, and y cubed and y reduced to y squared on top. And we're left with 3 times y squared times 2 over b times 2 times x. Where did I go wrong? That's a 5. Sorry. That's not a 2. That's a 5. I was about to say that's not right. That's this 5 right here. Sorry about that. Okay. 3 times y squared times 5 is 15y squared. And then b times 2 times x is 2bx. There we go. Okay. Next we have 16mt squared over 21a to the 4th b cubed. That part stays the same. Times, now we have to multiply by the reciprocals, so we're going to flip this second fraction over. We've got 7a squared b squared over 24m cubed. Okay, now I want you to take a second, reduce this. I'm going to get some things out of the way, so that we have a little bit more space to work with. Alright, I'm assuming you've worked this out, so if you haven't, please pause the video now. Okay, let's reduce. 16 and 24, there's an 8 in common, so this becomes 2, this becomes 3. 7 and 21, there's a 7 in common, so this becomes 3, that becomes 1. We don't need to write it. A squared and a to the 4th reduces to a squared on the bottom. B squared and b to the 3rd reduces to b on the bottom. M and m cubed reduces to m squared on the bottom. And t squared stays. So we are now left with 2 times t squared over 3 times a squared times b times 3 times m squared, which gives us 2t squared over 9a squared b m squared, which is in fact correct. Okay. The third one, this is what we call a complex fraction. So this is what we call a complex fraction, this right here. Okay, so a complex fraction has two parts. We have the top fraction here and the bottom fraction here, and it's this fraction divided by that fraction. So effectively, we're doing the same thing here as we have been doing. We keep the first fraction the same, and we multiply by the reciprocal. So 16a squared x over 6x squared y to the 4th. This is equal to well, let's reduce. So yeah, take a moment to reduce. I'm going to jump ahead here. Oh wait, that does not reduce with anything. Alright, now you'll notice there's an x and an x squared on top, so our final answer is going to have x cubed in it. Now, let's see, what do we got? What do we got? This is 2 times x squared times 2 times x over 5 times a squared times y squared. This is equal to 4x cubed over 5a squared y squared. Alright, now for the last one, we have polynomials. This is the kind of problem that you'll typically see associated with multiplying and dividing rational expressions. Okay, 3 factorable trinomials and 1 binomial that's standalone. Okay? So here we have to do some cross puzzles. Now the first one is right here. It's x squared minus 6x minus 16. Alright, so this cross puzzle is going to feature a negative 16 on top and a negative 6 on the bottom. Take a moment to figure out what those two numbers are. Meanwhile, I am going to adjust the lighting a little bit. Alright, hopefully this is a little bit better. I'm going to see if I can adjust my camera settings as well. Oh, that's way better. Oh my goodness, that's fantastic. Okay. So negative 16 on the top, negative 6 on the bottom. Oh, that's so much better. The two side numbers that multiply together to give negative 16 and add together to give negative 6 are negative 8 and positive 2. So because these are our two side numbers and the leading coefficient on this polynomial is 1, that means we can rewrite this top part as x minus 8 and x plus 2. Now, we should all know how this process works by now. If not, I recommend checking out other videos on factoring trinomials, because this is something that we have done throughout the course of 3 different units at this point. Okay, moving on. This second trinomial, let's make another cross puzzle for it. This one has positive 64 on top, negative 16 on the bottom. Let's figure out the two side numbers. Alright, I'm assuming you've tried this, and you should get negative 8 and negative 8, which means we can rewrite this as x minus 8 and x minus 8. Alright, now there is one more. I need another highlighter. I only brought 2. Okay, hopefully this one works very well. Also note this is multiplication, so we don't have to flip this over. Now on the top here we have x minus 8. This cannot factor. So we've just got x minus 8 here, and I strongly recommend that you put this in parentheses. I'll explain why in a minute. Now for this last one, this right here, x squared plus 5x plus 6, that is another factorable trinomial. When it comes to rational expressions, if you see trinomials, typically that means you can factor them. Alright, at least at the Algebra 2 level. Okay, we have 6 on top, 5 on the bottom. Two side numbers here are 5 and 1. So we've got x plus 5 and x plus 1 as our two factors. Okay, now instead of doing reduction, we straight up do canceling. Now, when you cancel, do not, and I repeat, do not try to just cancel x's. That never ever works. That is not something you can do. That is not something that you can do. The only thing that can cancel, and this is because it's addition and subtraction involved. Addition and subtraction with fractions murks everything up. Okay, so because of this, what you want to do... Oh, I made a mistake. The first thing that I want you to do is figure out where I went wrong. That's what I want you to do real quick. The first thing that I want you to do is figure out where I went wrong. Alright, once you've done that, the two side numbers are not 5 and 1. Two side numbers are 3 and 2. Which means this is x plus 3 and this is x plus 2. There we go. Now we can move on to the cancellation. So don't cancel the x's. Instead, you have to cancel the full terms. So for example, the only thing it can cancel out this x minus 8 is another x minus 8. So we've got these two that can cancel. Then x plus 2 and x plus 2. Then x minus 8 and x minus 8. So yeah, sorry if you got 3 and 2 and then I put 5 and 1 and you were utterly confused. That's my fault. I had them flipped. Alright, so what are we left with? Well, on the top, everything canceled. But we can't just leave the top blank. We still have the x plus 3 on the bottom. So what do we put? Well, we put 1. When everything else is gone, really what you're effectively doing is you're reducing, when you cancel something out, you're reducing it to 1 over 1. So because of that, we're left with 1 times 1 times 1 on the top, and then 1 times 1 times 1 times x plus 3 on the bottom. So because of that, we have a 1 on top, effectively, every time we do this. And there's nothing left. The reason why we didn't put it earlier in the problem is because it was on the bottom where everything was canceled. And so we could effectively write this as ACD over 1 if we really wanted to, but we don't really need to. But here, 1 over x plus 3 is not the same thing as if we just put x plus 3, right? That's not the same thing. So because of that, we actually need to write the 1 as a placeholder. Yeah, again, apologies for this mistake here. It's been a long day. Alright. Work on the sample problems. Hopefully this didn't trip you up super badly. I'm going to scoot this up real quick just in case some of this did not show up clearly before when I had the substantially worse camera quality. Alright. And I am going to do the remaining sets of notes that I have to get done, and then I am going to go to bed because it is quite late.